Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, good morning, good afternoon to student from BDA 34103 numerical method for section 3 and 4. Okay, this is a recorded version for your class on tomorrow, which is 18 April 2023, about chapter 3, linear method. Okay, linear equation method. So I am sorry, okay, I have to record this video in early version due to because I have a difficulties to attend the class, but it's okay. We will have a refresh class after this after the recorded version. Okay, so as usual, before we proceed for the next topic, I will refresh, okay, the previous topic that we covered on your last class. Okay, so on the last class we already covered on LU decomposition Thomas method, okay, which is based on our RPP or lesson plan. For chapter 3, beside Doolittle and Crowd, we also have to study about the Thomas method and Thomas algorithm before we proceed on Gauss-Seidel iteration, which is we will learn on today. So basically for Thomas method variant 1, okay, as same as Doolittle and Crowd. Okay, basically you already know about the difference between Doolittle and Crowd. Okay, Doolittle L equal to 1 for diagonal, and for Crowd the diagonal of matrix U is 1. Okay, so and for Thomas method variant 1, okay, actually here we go through, they are slightly same, but the difference is between the matrix L and U is, okay, the arrangement or the symbol of alpha and beta, the location here lah. Okay, whereby the matrix U, the diagonal is 1 and the upper is beta. Okay, while in the matrix L, the diagonal is alpha, and then followed by the C3. Okay, okay, the rest is this one is fixed. Okay, we have to identify. So we proceed on example. Okay, this is a refreshment. I'm not. I don't want to teach again atau learn again. Okay, but this is just a refreshment. Okay, for example 3.6, actually we have a matrix A, matrix X and matrix B. Okay, which is this one is 4 by 4 matrix. Okay, 4 by 4 matrix. Then we got a matrix A like this one 1 2 0 0 3 4 5 0 and so on. So we see for the solution wise ni, okay, the arrangement of matrix A, okay, same, but the arrangement for matrix L and matrix U is like this. Okay, whereby the element, okay, the upper element in matrix L is 0, while the lower, okay, element in matrix U is 0. The rest is something like this Okay, matrix L, the diagonal is alpha, while the matrix U, the diagonal is 1. Okay, and then based on this one, you compare to identify the respected value of each element. Okay, what is the value of alpha 1, alpha 2, alpha 3 and alpha 4. Okay, this is something like Doolittle and Crowd method procedure. Okay, slightly same. Then you have to compare the element by element based on the calculation table here. And then after you identify all the elements, okay, alpha 1 and beta 1 and so on, and then you have to get back or you have to reconstruct back the metric L and metric U until you get the metric Ly equal B and metric Ux equal to Y to identify the metric or the element of X. Okay, so basically for this step, okay, you might not use a Gauss elimination method, but you can also only use the simple, okay, linear equation based on the metric equation in your calculator. So you solve by using calculator. You just key in the element here, okay, and then the metric B here, and then you will simplify, get the value of Y. Then you repeat again the process to get the element of x1 until x4. Okay, do not use manual calculation or manual Gauss elimination method, but only use your calculator. Okay, basically for variant 2 is not covered in our lesson plan, so I proceed for this is a refreshment again. This is a refreshment version. So for Thomas algorithm, slightly same with the algorithm, Thomas variant 1 method, but if you can see here, the metric A, metric L and metric U is slightly a bit different in terms of this one, okay, D, C and E. Okay, while this one is there are no such of, okay, D, C and E, okay, slightly same. Okay, and then okay, this one. Okay, where the E, okay, the process is same, okay, same like the variant one, whereby we compare the element by element based on the metric A and metric L and metric U. Okay, after we get the element of after we get the respected element, okay, let's say we got the beta 1, okay, the value for beta 1, and then we solve, okay, by using this one, metric L multiplied by metric Y to equal to metric B. So we get the element Y, and then we repeat by using this one, Ux equal to Y, okay, to get the element X. So from the element comparison, we can generalize that the alpha 1 is equal to D1. Okay, then we compare back. So the alpha I equal to D, and then you get the beta I. Beta I is equal to EI. This is the fixed formula that you can follow. Okay, then we combine by using the calculation table. Okay, D, E, C and B is the element. Okay, you just compare in the metric A. Okay, D, E and C you can get from here. Okay, D, okay, this one, D, this is a metric A. Okay, this is the diagonal. D is the diagonal of metric A, while the E is the upper and C is the lower element. So let's say you got let's say okay, let's say this is the example of metric. Okay, this one, okay, metric, this one metric A. Okay, this is the D. Okay, this is the E and this is the C. Okay, so this one is C2, C3, C4, E1, E2 and E3. So then kita balik lah. Okay, so remember in C they are starting with the C2, there are no C1. Okay, but and for the EI ni, okay, let's say 4 by 4 matrix, then the E is only up to E3. There are no E4. Okay, remember this. Okay, and then the rest is you just compare the element to get the respected value of the symbol to alpha 1, beta 1 and so on. And then for today, okay, this today 18 2023, okay, Gauss-Seidel iteration method is slightly same with the previous method, Thomas algorithm method. Okay, consider an equation with an unknown variable. Okay, there are such. Okay, let's say 3 by 3 or 4 by 4. And 4 by, okay, 3 by 3 or 4 by 4. Okay, in the question, in the test, or in the final. Okay, basically the question is asking you up to 4 by 4 matrix. Okay, there are no such 6 by 6 or more than that because it's time consuming. We try to avoid time consuming. Okay, so for the Gauss-Seidel, the unknown variable x can be solved by using Gauss-Seidel iteration formula. Okay, this is the formula, the fixed formula that you have used to solve the linear equation by using Gauss-Seidel iteration formula. Okay, in order to get the new number of x, okay, xi ni, k plus 1, you have to put the b. Okay, b is the matrix b lah. Okay, matrix b, and this one is matrix a. Okay, and the rest is you have to minus the element that not in the line. Okay, later on I will explain. Okay, however, to use Gauss-Seidel iteration method, the matrix A must be diagonal. This is the first, okay, first row diagonally dominant. So you have to ensure that the matrix is diagonally dominant. Okay, let's say this one. Okay, for example, this one. Okay, just saw the diagonal element here. Is it diagonally dominant or not? It's not, because one is lesser than the others. 5, okay, 5 is lesser than others, and 0 is lesser than. So the term diagonally dominant is meaning that the diagonal element ni, this one should be higher, or the value is higher than the others. Okay, let's say this one, after we arrange, okay, okay, from this one, okay, we just highlight the maximum or the highest number or value in respected row. Okay, this one row 1, row 2, and row 3. Okay, this one from in the row 1, what is the highest number? 7, right? Okay, 7. And then what is the highest number in row 5? Please neglect the plus or minus symbol, just modulus it, just modulus. Okay, 9. Okay, 9. And then in row 3, what is the maximum number? What is the highest value? 5, right? So at first we saw in row direction. Okay, row direction. And when we want to rearrange, we must look on vertical or in a column direction. Okay, let's say this one. Okay, from this one to this one, in column 1, the highest number is 5, right? We already, so we put in row 1. Okay, this one. And then we go to the next column. Okay, next column, the second column. In the second column, the highest value is 7. 7 is located in row 1. So since the 7 is located in column 2, so this row should be rearranged to row 2, and this one, the column number 3, the highest one is 9, so 9 should be rearranged to row 3, like this one lah. So this one, row 3. So row 1 to 2 row to row 2, row 3 to row 1, and row 2 ni to row 3. Macam itulah. Ubah-ubah. And then you will get this one, this number. Okay, which is 5 is highest than others, 7 is highest than others, meaning that 5 is higher than 1 plus 0, 7 is higher than 4 plus 1, and 9 is higher than 2 plus 5. Neglect the plus or minus symbol. Okay, like this one, modulus. Modulus. Okay, this is correct. Then once you got the diagonally dominant, then you can go through for Gauss-Seidel iteration method. There are some question in the test or final. They are asking you about, is it the equation is can be solved using Gauss-Seidel iteration method or not. So you have to very particular, or you have to identify, or you have to determine the metric first. Okay, the metric element, the metric A lah. Okay, you have to compare this one to identify either this metric, the given metric is diagonally dominant or not. If not, then you have to reconstruct ataupun rearrange. If you cannot get this one, okay, let's say this one 5 is higher than other. Let's say 1 ni is replaced to 3. Okay, and this one is katakan 3 also. So 5 is we cannot put higher lah, because 5 is lesser than 3 plus 3. So in this case, this equation or this metric cannot pass through this Gauss-Seidel iteration method, so you cannot proceed. This is the rules number 1, the diagonally dominant. Okay, and then the solution step for Gauss-Seidel iteration. Let's say we already get the metric, the diagonal metric. Okay, this one. The solution step for Gauss-Seidel iteration method can be summarized as, okay, step 1, rearrange the equation if necessary, such as metric is diagonally dominant. This is the step number 1. And then step number 2 is you have to write down the Gauss-Seidel iteration formula based on this one. Okay, B is metric B, A is metric A, and then you have to minus the others element. Okay, and then step 3, make the initial guess and iterate using Gauss-Seidel iteration formula until maximum. This one the condition lah that given during the test or final ataupun assessment. This is considered macam convergence topic criterion macam tu lah. Okay, we proceed on example 3.9. Okay, it's given. Okay, again this is a metric A, this is a metric X, and this is a metric B. Okay, so and then you have to easy for me lah to recall. Okay. Okay. So the question is, solve the system of linear equation using Gauss-Seidel iteration method. Iterate until maximum xk plus 1 minus xk is less than 0.05. This is the error lah. Okay. So now proceed. Okay, and then we go to the solution. we have to determine either this matrix, the matrix A matrix ni, is diagonally dominant or not. Okay, just highlight lah. Is it diagonally dominant or not? No, right? So if no, then you have to rearrange. How to rearrange? First, you have to solve the matrix A based on the row direction. Row direction, row 1, row 2, row 1, row 2, row 3, row 4. Okay, in row 1, okay, what is the highest value? Please neglect the plus or minus symbol ni. Okay, just modulus the value. Okay, 7, right? Okay, and then the second one, what is the highest one? Is minus 9. The third one, what is the highest value is 3, and then the last row, the highest value is 5. Okay, and then we saw in column direction. Okay, column direction, this one for column direction, row and column. Okay, for column number 1, okay, the highlighted value is 3. So 3, okay, 3 ni, from row number 3 ni, you should rearrange to row number 1. Okay, and then column number 2 is 5. 5 from row number 4 ni to row number 2. And then third column, the highest is 7. So from row number 1 should rearrange to row number 3, and then column number 4 ni, the highlighted value is minus 9. So from from second row to fourth row, the row number 4 lah. So this is the process to rearrange the row, the matrix. You have to rearrange all the element, all the element. Okay, let's say this one, from row 1 to row 3. Okay, all these things. So in this case, the matrix B also affected lah. So in this case, okay, once you already rearrange, then you can compare this one. Okay, matrix B, the original one, and the rearranged one. 2, 5, 3, 3. This one is 3, 3, 2, 5. It's different. Okay. See, so once you rearrange, okay, you got some marks lah. Okay, regarding this process. Okay, and then write down the Gauss-Seidel iteration formula. Okay, how? Okay, this is the formula. Okay, BI minus the summation of AIJ multiplied by XJK plus 1. K plus 1 is the following apa ni, the recent, okay, the recent iteration. Okay, tak apa, it's okay. I will not explain first. Okay, we saw the apa ni, the solution. Okay, the during the ni lah. Okay, the table. Okay, so in this case, okay, this is the matrix that we already rearranged. 2, 5, 3, 3. 2, 5, 3. Okay, this one the rearrange matrix. I put MAX is meaning that matrix. Okay, okay, this one. If you can compare, okay, B, matrix B, B, this one kan, B1, B2, B3, B4. Okay, here B1, BI, BI. So this one X1, 2, 3. This because the matrix is 4 by 4, so you should have 1, 2, 3, 4 element lah di sini. So let's proceed on X1 first. Okay, On x1, the bi is 2, right? 2. So you put 2 here. This is the fixed number. Okay, 2. Okay, based on the question lah. Okay, if the question or the metric is, let's say 9, so you should put here 9 lah. Okay, this one is the B metric element. Okay, 2 minus, okay, x2. Okay, in this case, what you want to highlight ataupun what the criteria or the term that you have to remember is the B element and also the A element. Okay, kalau kita tengok sini from here, 2533. Okay, 2533. So you just write down 2533, and then the rest. Okay, this one 3, 5, 7, 9 ni is the matrix A. So this one in diagonal, in terms of the diagonal. Okay, the diagonal element in matrix A. Okay, that's why they put here A, the diagonal element. So 3 minus 5 minus 7 and minus 9. 3 minus 5 minus 7 and minus 9. So this is the element of matrix A, and this is the matrix B element. Okay, the rest is followed by this one. Okay, minus. Okay, because the equation is minus. Okay, so if let's say this one plus, okay, you got plus something like this. Okay, minus. Okay, so when you minus plus minus, and you can get the plus lah, like this one, plus 3. So 2 is B. Okay, which one? 2 minus x1. X1 is because this one 1 lah. Let's say this one, yang ni, okay, yang ni, let's say 10. So you have to put here 10 lah, minus 10x 2. Okay, let's say this one 8. So this one minus 8x3. Then sebenarnya ada lagi ni, minus 0x4. This one. So macam tu lah. So when you got the 0 number here, then you neglect this one. Okay. Okay, same goes to the second iteration ataupun second element, which is x2. Okay, x2 we are using row number 2 ni, B 5 ni. 5 plus. Why plus? Because you got minus. So minus and minus and minus, you got plus lah. Okay, plus x, and then minus 2. Okay, in this case, the diagonal, okay, the diagonal, this one, this one, this one, and this one should put in here. Okay, diagonal. Okay, the rest you put here in A element lah. Okay, and this one is B element, B matrix element. So I believe that you clear. If you still not clear, then we will have a refreshment discussion in our class on the next series of class. Okay, and then step 3, take initial guess. Okay, x power of 0 ni. This is the transpose. And then step 3, iterate the Gauss-Seidel iteration formula, meet the stopping criteria. So in Gauss-Seidel iteration method, okay, after we got this one, we will put in metric like this one. Okay, so you have to convert, okay, from this A, B, C, D ni, A, B, C, D, x1, x2, x3, x4 ni to be A, B, C, D. This is the calculation version lah, calculation version. We want to compare x1 to x2, x3 and x4, so we are using different type of character. We use character A, B, C and D. And this one, Okay, same. Okay, I will padam jap. Okay, sini. Padam. Good. Okay, this one 2 2 minus x2. So x2 is b, a, b, c and d. Okay, so any x3 apa macam ni kan, x4 lah, x4 is d lah, d. This one d, this one d. So you have to convert into the calculation punya character a, b, c, d. 2 minus 2. So this equation or this character ni are based on the question given in your assessment, in your test or in your final exam question. So it might change. Okay, let's say in this one you got minus, katakan dekat sini let's say this one minus, so you should not minus c, but you just minus 0 lah, because this one 0. So all the element here are based on the question given, okay, the value given in the question. Okay, then we put in formula table formula, which we start with k or I lah, meaning that the iteration, and the iteration is, if you can see here, the iteration must start with 0, must start with 0. Please, please, I highlighted it many times. Okay, and then we put x1, x2, x3 or x4, or in your punya calculation character we put a, b, c and d, and then e is error for this one x1, and this one error for x2, error for x3 and error for x4, macam itulah. Then the maximum error. So since we got no number, okay, in iteration 0, so we just put 0 here. Okay, and then okay, this one you supposed to type lah in your calculator. Okay, let's say right now you get your scientific calculator, and then you write like this one. Okay, a exactly same, this one a equal to 2 minus b minus c divided by 3. Okay, and then you put it like this one, b equal to 5. Okay, something like this one. Okay, you write down, okay, a equal to 2 minus b minus c divided by 3, and then you put this one double dot, and then b equal ni. Okay, and then the rest you press shift plus dengan calculator kan. Shift plus calculator, and then the computer or the calculator will ask you what is the value of a, what is the value of b, what is the value of c, and what is the value of d. So you just masukkan lah. Okay, you have you just key in the value of that particular value tu So in this case okay, in this case you put a, b, c and d tu is 0 lah. A, b, c, d and is 0, and then you will get this number, and then again the calculator will ask you what is the value of A. So you put A is 0.6667. What is the value of B? So since we got no value for B yet, so we just put B, C, D and B, C and D is 0, and then you will get the new number of B. Okay. And then you just press again, and then the calculator will ask you what is the value number of A. So you use this one 0.667, and then what is the value of the current value of B. So the current value of B is 1.13. What is the current value of C? We don't have yet, so we just put 0, and then D is 0, and then later on you will get the value of C, and then the process is repeating until this one. Once you got this one, then you have to identify the error. So how you are going to get the error is by deduct ataupun by minus, okay, the previous the recent one to the previous value. Okay, let's say this one, okay, 0.6667 minus 0 is 0.6667, same. But okay, and then we proceed on the second iteration. Okay, let's say we the calculator, okay, will ask you what is the current value of A. The current value of A is 0.667 still, okay, still. And then what is B? B is 1.1333 ni. Then C is this one, X is this one. Then later on you will get the new value of A, element A ataupun X1, eh. Then again lah, okay, you put A is 1.079, and then B is 1.13, C is 0.104, and D is 0.04. Okay, then you will get the second iteration. Same goes to the third, fourth, fifth and so on. So how we are going to stop this iteration is based on the maximum error. So how we got the maximum error is based on our observation. Okay, you just observe. Okay, in this case, what is the maximum error? The maximum error is 1.133, and then based on error number 1 until error number 4, what is the maximum error? The maximum error is 0.4127. Okay, this one. Okay, until you got, okay, this one less than 0.005. Okay, in this case you got 0.0014. Okay, so then you have to stop. So what is the number? The number is this one. This is your number. Okay, X1 is 1.128. Okay, in your punya question ke apa, you boleh tulis macam gini lah. X1 is equal to 1.128, X2 equal to 1.2493, X3 equal to ni, X4 equal to ni. Yeah, equal to this one. So that's it. Okay, so you already complete this topic 3 lah, which is you are eligible to attend ataupun to sit for test 1. Okay, test 1 is covered on topic 1 error, topic 2 nonlinear, and topic 3 linear equation. So see you again in the class. I will did some refreshment regarding this topic, and yeah, good luck for your test 1, and happy Hari Raya, okay, for Muslim, and happy holiday lah for non-Muslim student. Okay, for assessment, yeah, dia apa? For assessment, okay, we just focus on previously this one Gauss elimination method. Okay, I will find out the previous maybe past year question ke about Gauss-Seidel method, Gauss-Seidel, and then you have to submit. Okay, this is your attendance lah. Your attendance are based on the exercise this one for today. Okay, okay class. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh, and good afternoon. Bye.